Today we are going to discuss about parabola. Parabola is a conic section. So at first we have to know what is a conic section. A conic section is a locus of a point in a plane such that the distance of the point from a fixed point S, that is SP, and the distance of the point from a fixed line, that is PM. The ratio of SP and PM is always constant. So, if a point P moves in a plane such that the distance of the point from a fixed point S and distance of the point from a fixed line, that is PM, if the ratio of SP and PM is a constant, then it is a conic section. If here the value of E can be greater than 1, can be less than 1, can be equal to 1. If E equals to 1, then it is called parabola. If E less than 1, then it is called ellipse, and if E greater than 1, then it is called a hyperbola. So, for today's chapter parabola, the constant E is equal to 1, that is SP by PM equals to 1, that is SP equals to PM. So, for parabola, the distance of the point from the fixed point and distance of the point from the fixed line is always equal. Now, we will learn about parabola. So, for parabola, SP equals to PM. Now, we know that the general equation of second degree is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0 is a parabola when AB equals to h square. So, the condition when a general equation of second degree will be a parabola is AB equals to h square, and delta, that is AAG, HBF, GFC not equal to 0. So, the condition for being a parabola is AB equals to h square and delta not equal to 0. Now, here this is x-axis, this is y-axis, and it is a parabola. Here P is any point on the parabola. The distance SP and PM is always equal. Here the point, fixed point S is called focus. The fixed line on the plane is called directrix. The point A is known as vertex of the parabola. The line L1, L2, this line is called latus rectum. Here the line which divides the parabola into two symmetric portions is called the axis of the parabola. Here x-axis is the axis of the parabola. So, the fixed point S is the focus of the parabola, A is called the vertex of the parabola, the fixed line is the directrix of the parabola. Here the line which divides the parabola into two symmetric portions is known as axis of the parabola, and the line L1, L2 is called the latus rectum of the parabola. Now, we will find the equation for a parabola whose vertex is at 0, 0 and the parabola opens to the right hand side, that is opens to the positive x-axis direction. Here focus of the parabola is a, 0 and m1, m2 is the directrix. Now the vertex is O, that is 0, 0. Now this distance is A, so this distance will also be A, because we know that any point on the parabola is equidistant from the fixed point and the fixed line. So if this distance is A, this is also be A. Now let P x comma y any point on the parabola. From the definition of parabola, we will know that SP equals to PM. So SP, that is the distance between the point x comma y and a comma 0, is root over x minus a whole square plus y minus 0 whole square, and PM is this distance. Now this distance is A, and this distance is, the point is x comma y, so this is x, this is y, so this will also be x, so this is x, A plus x. Squaring both sides, we will get x minus a whole square plus y square equals to a plus x whole square, or y square equals to x plus a whole square minus x minus a whole square. We know that a plus b whole square minus a minus b whole square equals to 4ab, that is 4ax. So we get the equation of the parabola is y square is equal to 4ax. So this type of parabola have an equation y square equals to 4ax. So we get that the equation of the parabola is y square is equal to 4ax. And for the parabola, the focus S equals to a comma 0, the vertex O equals to 0 comma 0, the axis is x axis, equation is y equals to 0, the equation of the directrix is x equals to minus a, the length of the length of the lattice rectum equals to 4a. It is 2a and it is 2a, total 4a. The end points of lattice rectum are a comma 2a and a comma minus 2a. So for the equation y square equals to 4ax, the focus is a comma 0, the vertex is 0 comma 0, the axis is x axis, y equals to 0. The equation of the directrix, that is the line m1 m2, is x equals to minus 1. The length of the lattice rectum is 4a, and the end points of the lattice rectum are a comma 2a and a comma minus 2a. Now we will find these for a particular equation y square is equal to 16x. So we have to find all these for the parabola y square equals to 16x. So here 4ax equals to 16x. So we will get a equals to 16x by 4x, that is 4. So we get the value of a. Now we will put the value of a in the above formulas. So the focus will be 4 comma 0. The vertex is 0 comma 0. The axis is also x axis, y equals to 0. The equation of the directrix will be x equals to minus 4. Just put the value, we put the value of a. The length of the lattice rectum is 4a. So here 4 into 4, that is 16. And the end point of the lattice rectum will be 4 comma 8 and 4 comma minus 8. So for any parabola, we can find all these things easily. Next class, we will discuss the other forms of parabola.